Hi, Madman here, and today we're going to talk about enabling physics in your Corona SDK project. I've got a little simple app here with two balls, and when you run it, the two balls fall to this green ground and they collide with each other and then they sort of roll off the screen. This is all accomplished using the physics library in Corona SDK, and so today I'm going to show you how to do this. So I'm going to bring up my text editor here, and we're going to start off with a blank project, and we're going to begin by enabling physics. Now, like other libraries in Corona SDK, say the Composer library, you're going to enable it by requiring it. So I'm going to set up a variable called physics, and I'm going to equate it to the require statement for physics. So this loads the physics library for us. Now that's not enough. We also need to start physics. So we'll do that by using the physics command, physics.start. And the start method will start the physical simulation. Now, let's begin by putting a ball on the screen. We're just going to use a circle, but you could do this with an image as well. But just for my demo here, I think it's easier just to use a circle. So I'm going to put it towards the top of the screen, centered. It's going to be 30 pixels in diameter. Let's go ahead and see what that looks like. Okay, looks a little boring. Let's go ahead and change the color to yellow. Alright, now we've got a yellow ball on the screen. Now physics has started, but the ball isn't dropping yet. Well, that's because we need to add a physical body to the ball. So to do that, you use the physics.addBody method. And the first parameter is going to be the object you want to add a body to. In this case, it's going to be the ball. The next parameter is the type of physical body you want to make. Dynamic means that they will interact with other physical objects that you've defined on the screen. Static means that they will not react to gravity, and you'll see that in play in a few minutes. So the next thing we're going to do is we're going to specify a table of optional parameters. Now I could stop right here, just enclose this, and we'd be fine. But I'm going to show you a few of the optional parameters that you may want to tweak later. Density is one of them, and that defines how dense the object is. Now the default value for density is 1, which is supposedly the density of water. Now, depending on the physical simulation and what you've got your physics scale set to, you know, your mileage may vary on this, on how realistic this actually is, but that's just a starting point. The idea here is anything with a higher density value will have more of an effect on other objects that have less density. So the density is going to be set to 1. Friction, we're going to set it to 0.3. I believe that is also the default value. And friction basically tells the simulation how much friction actually affects the body in its in the environment. So think about a ball rolling on a golf course. If it's rolling across a green, it's going to run pretty fast. But let's say it hits the rough, it's going to slow down quite a bit. So that's friction involved right there. So finally, the other parameter I'm going to show you is the bounce parameter. And the default value for that is 0.2. And that's a medium bounce. And anything above 0.5 is going to be pretty bouncy. So I recommend you play around with those values just to see what effect they have. I think you'll find you'll have a lot of fun doing that. Okay, so I've completed the parameters. I'm going to go ahead and save that, and we'll see that our ball falls off the screen. Okay, well, I think we want to do something about that. Why don't we add a floor? So the next thing we're going to do is add the ground. So ground equals, we're going to use a rectangle for this, display.newRect. And we're going to center it on the x-axis. Height times 0.8. We're going to put it down towards the bottom of the screen. And the length is going to be the width of the displayable area, display.content width, and the height is just going to be a fraction of the height of the screen. And I believe that's what we want. Let's see what we get. You got a little error there. Let's take a look. Display new rect, display content center X, display, got a comma here. Let's get rid of that. Let's try it again. Okay, there we go, and it fell right through my ground. Well, okay, two problems. I don't like white for the ground. We're going to change that to green. Ground dot colon set fill color. There we go. That should make it green. Still falls through the ground. We want to fix that, and we do that once again using the physics.addBody command. So we're going to do that, and we're going to change the ball to ground. We're going to try that and see what happens. Okay, well that was fun. So what happened was the ground fell with the ball. That's not what we want to happen. So this is where that static body type comes into play here. So we're going to make this a static type. Let's see what happens. There. Okay, good. So now the ball drops and it just sits there. So let's experiment a little bit with the bounce. Let's add a little bit of extra bounce to the ball. So I'm going to modify this property to 0.5. Let's see what effect that has. And you can see it bounces quite a bit more. Why don't we try making it quite bouncy? Give it a 1 value. You can see it just bounces quite a bit there. And it returns to approximately the same place. It varies, and that's all because of friction, the friction value we've set there. Ideally, with no friction and equal bounce, the ball would return exactly to where it started in the simulation. Okay, let's go ahead and let's change the gravity a little bit. Now, I don't think that the rate at which this ball is falling is really realistic in a Earth environment, so I like to mess around with the gravity setting. So physics.setGravity. Now there are two values here. It's going to be the gravity pull on the x-axis and the y-axis. So on the x-axis, I'm going to say gravity is 0, which means I don't want it to pull the ball to the left or the right. I want it to just leave it alone. But the next one, the y-axis, the default is 9.8. Now, we already are at 9.8. I'm going to increase it to, let's say, 15. And let's see what effect that is. Now, a positive number is going to pull it down more, and a negative number will reverse gravity so that the ball will actually float up off the screen. So let's see what happens when we do that. Now that bounces a little bit more. Yeah, so that falls a little bit quicker. So why don't we increase that gravity just a little bit more? Let's try 20. And even better, maybe we'll go up as high as 25 and see what happens. Yeah, I'm liking that. That seems fairly realistic. So we're going to go with that. Let's go ahead and play around with objects and how they collide with each other. We're going to add a new object, ball 2. And I guess I'll just copy this. Let me just copy this whole thing. Let's group these together. And do that. We'll name this object ball 2. And we're going to make it just centered in the middle of the screen. So let's just try that and see what happens. Oops, I have to save it. There it is. Okay, obviously I don't have a physical body on that ball, and that's because I've added 2 physical bodies to the same ball. We don't want that, so let's go ahead and change that. We'll give them the same properties, and also I think I want to change the color of ball 2 to be red, so do that. Okay, so notice how they it's kind of weird how they don't really roll off each other. They just kind of balance on each other, and that's not really realistic. Let's find out why. Now, there's a useful troubleshooting tool in the physics library in Corona that allows you to set the draw mode of the simulation so that you can see the physical boundary. And now you can see why it behaves so oddly. The default shape of a physical object is a square or rectangular. So that isn't going to really make for an especially realistic simulation. So luckily, we can override that behavior. We can add a new parameter to our physics.addBody command for each of these objects. And so I'm going to use the radius keyword here, the radius property, and we're going to set it to be the same radius as the circles. So I'm going to add that there, and I'm going to go down to the second one, the ball 2, and I'm going to add radius equals 30 there, and we'll save it. Let's see what happens. Okay. Wow, look at that. It's just perfectly balanced. And that's because they are right on top of each other. If we were to, say, offset it slightly, like that. Let's take a look at that, and now you see it actually behaves the way you would expect it to behave. I suppose it's possible that if you had that perfectly centered content center X, in the real world, 2 objects might balance like that, but I find it a little bit hard to believe. You never know, though. Okay, great. So that is a basic overview of implementing physics in your project. Now notice I can't really do anything with these guys. I can't click on them and touch them, move them around. That's going to be in our next tutorial on touch joints. So join me for that. Please check out my other tutorials on Madman's mobile app dev channel. Thanks.